All right, guys, here is part 2. I got cut off on that previous video, so let's finish up. The steps for solving a system by elimination or as a linear combination. This is where I got cut off here. Step 1, if we need to, we multiply both sides of one or both equations so that the coefficients of one of the variables have the same absolute value, meaning that we have created a zero pair. A positive 3 and negative 3, a positive 4 and negative 4. After we've done that, then we're going to combine the equations to eliminate a variable. We'll then solve the resulting equation. Because it will only have one variable, we can solve by simplifying, isolating, and isolating. Once we have solved for that one variable, we then find the eliminated variable. We can do that by substitution, which we did for most of our examples, or just start from the beginning and eliminate the other variables. So if we eliminated the x's the first time, we can go back to the beginning and eliminate the y's the second time, whichever way you prefer. Finally, last but not least, we write our solution as an ordered pair. And again, this is written so that we know which one is the x and which one is the y. By writing it as an ordered pair, we have an x and a y, and we know the exact order that they're in. We want to check our solution by substituting it back into each equation to make sure it is an actual solution. If it produces a true statement like 4 equals 4, it's a solution. If we plug it back in and we get 4 equals negative 7, then our solution is not right. We need to go back and we need to fix it. So don't forget to check your work and check your solution. All right, guys, it was just that small little part we needed to finish. So today, you solve systems of linear equations by the elimination method, also called the linear combination method, and we did that by creating zero pairs. I'll see you guys in class. Make sure you write down any questions that you have.